Good morning. Hopefully you guys are doing well. I'll wait a couple minutes, see if a few more people join. Is the mic any better? Tell me if the mic is any better. Good to see you ladies this morning. Good morning. It'd probably help if I took the mask off, sorry. Forget about it sometimes. Good morning, good morning. Wait to see if a few more people join. Since we only have 2 viewers right now, it seems like maybe some people came on, put their name in, and then left. Okay, but for those who are here, okay, I emailed you, so check your email. I emailed you our quiz for today. Okay, quiz 8. You don't have to print it. You can just use a blank sheet of paper. Just put your name, class, date, assignment. So just put Ellie Lara, Bible, or 11th to 12th Bible, or Life of Christ, either or. The date, and then put quiz 8 on the top of the page so I can know what it is. And then you can take that now. That's all we have for today. So I'll announce it again once a few more people are on, but that is what we have. Good morning, Grace. Good to see you. We have that quiz, and that's it. Can you guys hear me? Let me know if you guys can hear me. We're trying out a new mic today. So let me know if it's any better or not really. Not much feedback this morning. Hey Grace, thank you. Hopefully the volume is better. Okay. Again, it doesn't look like any more people have joined. We have a quiz this morning. Okay, so you can just go and take that quiz. I emailed it to you, so go check your email. Good morning. Good to see you. Okay, Jacob, I messaged you. I need your email. I thought I had it, but I couldn't find it. So if you could send that to me so I can send you your quiz. I sent it to everyone else. That's all we have for today. Okay, so that quiz is going to be sent to the email you gave to me. So check the spam in case maybe it might be in there. That is due today. Okay, again, you don't need to print it out, but what you can do is just take a blank sheet of paper, name, class, date, assignment. So Nicholas Coral, Life of Christ, or 11th to 12th Bible, the date, and then on the top of the page you'll put quiz 8. And then you just put 1, the answer, 2, the answer, and then for the essay, just put 6 through 10 and write your essay. Okay, that will be due today. If it's not turned in today, you won't receive credit. Okay, so for those who already have heard, okay, you don't have to stay on the stream for the rest of this class. I mean, you can, or you can just leave it there chilling. Okay, but you guys can go and take your quiz if you like. That's all we have for this hour. If you have any questions, again, you can message me or throw it in the slot. Good morning, Emma and Esther. Okay, I just announced it, and I'm going to be announcing it once people join. Okay, all we have today is our quiz. Okay, I emailed it to the email you gave to me and Mrs. Coral before Thanksgiving break. Okay, so check your email, possibly the spam. If you don't see it in your email, it could have slid into the spam. But make sure you get that. Just take a blank sheet of paper, make sure your name, class, date, and assignment's on there, and then put quiz 8, the assignment, on the top of the page. And then you'll just write 1, the answer for number 1, 2, vice versa. Okay, I sent the quiz to everyone. Jake, I need your email so I can email you the quiz. I thought I had it, but I can't find your email, so I need you to send me your email. Once you send me your email, then I can send you the quiz. Good morning, Jaylene. Again, the quiz was emailed to you. You need to check your email. It's right there. Okay, it's just a picture of it. I sent it to everyone except Jake because I could not find your email. I thought I had it, but I can't find it. So I need you to resend that to me. Okay, the email or the quiz was sent to your email. That's all we're doing for today. So if you've already heard that, you can either go off the stream for the rest of this class and then jump on for history, or you can just let it sit there and mute it or something if you like, or just let it sit there. And you'll take the quiz this hour, and it's due by the end of today. Okay, if it's not turned in, you will receive a 0. Okay, you need to make sure you're on time turning in that assignment. Good morning, Christian. Okay, I emailed, just like I've been saying to everyone as they join, okay, I emailed you your quiz 8 for this morning. Okay, so you're just going to go take a separate sheet of paper. You don't have to print it if you don't want to. Okay, it's just a picture. And you just take the quiz. Name, class, date, assignment. Make sure it's on there so I know whose it is and what quiz it is. I'll grade it. But make sure that's turned in by the end of today. If it's not, you will receive a 0. It was sent to the email you gave me. Okay, Jacob, I just sent the quiz to you. I found that email. If you guys have any questions, you can message me, email me, or throw it in the chat. No, your email wouldn't, but I just sent it to you. I found it on my other email. I just sent you the quiz. It should be coming from my iCloud email, nicholas0117@icloud.com. Okay, so Jake, you should have that. Ellie, you should have the quiz as well. Okay, check for it. Yes, I am emailing it. Welcome, Noah. Okay, we're just taking our quiz. You should have all received it. If not, I'm going to send it again right now. Okay, but you should have all received it. I'm sending it again just in case. What's going on? Yes, check those emails. It should be there. It says sent. If you still don't have it, let me know. Throw it in there that you don't have it. Again, we're just taking our quiz this morning. I sent it to all of your emails, so it should be there. Okay, if you don't have it, let me know. But the email you gave me before Thanksgiving break, that's the one I sent it to. Still don't have it. Interesting. I'm going to try it again then. There you go. I know Esther received it, so everyone else should have received it because she just sent it to me. Jake, check it's your iCloud. That's the one you gave me, your email. J Cafaro something, iCloud. Okay, check that. Quiz should be there. If it's not, let me know. Okay, Jake, did you find it? Does everyone have it? If you have any questions, let me know. Okay, that quiz is there. Some of you have already sent it to me. I've already graded them. I'm putting the grades in as soon as I get it. That'd be easiest. Any other questions? Does anyone have any questions? Okay, once you're done with it, you can just send it on over, whether through text or email, whatever works for you guys. Okay, just get it on over by the end of today, preferably this hour. I mean, it's not hard. Is the volume working better? Someone let me know. Is the volume working better today? Still not great, just a little better. Thank you, Kylie. I just got yours as well. Thank you, Christian. I just got yours. Again, if you have a question or you don't know what to send it to, I mean, just let me know. But you guys should have my number or email. All right, just checking in on you guys. Did everyone receive the quiz? A lot of you guys have taken it and sent it to me already. That's awesome. That's what I would prefer. We have about 10 minutes left, so if you did not, okay, you need to tell me now so I can get it, try to resend it to you. If you don't know what email I sent it to, you can ask. I'll tell you. Hopefully everyone's power is back going. Thank you, Jacob, for letting me know. Take it as soon as you can. It shouldn't take you long. What's up, Ian? It's a little late. Thank you. Awesome. That's all you have. Just take that quiz. Okay, send it to me as soon as you can. But if it's not turned in by the end of the day, you will receive a 0. Are there any other questions? Does anyone have a question? Did anyone not receive the quiz? Thank you, Noah. I just received yours. Okay, for everyone, you can be dismissed, and we will see you back in about 14 minutes for government. We'll see you later. Let me know if you have any questions. All right, welcome back for government. Hopefully you guys were able to use that time wisely and to finish up that quiz. Again, if you did not, that quiz is due by the end of the day. If I don't receive it by the end of the school day, you will receive a 0. Because it is Friday for those normal distant learners when everything's due anyways. And then those for who's just distant learning this week. Okay, that is just how we're doing it for quizzes. Homework you don't have to turn in. A few people did. Okay, that's fine. Homework you can just turn in person once you're back. Yep, you can email it to me, you can text it to me, or you can use My School Works, whatever works for you, Jake. Try to give you guys options, so whatever is best for you. Are there any other questions on that? Did everyone get it? Did everyone get the quiz? Okay, we're going to jump right into government. Okay, before we do, we're going to pray. So if you guys have any prayer requests, throw them in the chat real quick. I'll give you guys about a minute because I know there is a lag. Throw prayer requests in the chat and we'll pray, and then we'll begin class right after. Give you guys about a minute to throw something in there. Okay, no prayer requests, so I'll just pray for the things that I remember, things we've talked about before, and then we'll jump right into class. Okay, here we go. Dear Heavenly Father, Lord, thank you for this day. Thank you for all the love that you give to us, Lord, on a daily basis. Thank you for everything you do for us. Thank you for the students, Lord, as they're here. Most of them doing their distant learning, Lord. Please allow this to be able to be somewhat educational and to do our best with what we have, the means to live stream class. Please help the students if they've been sick, Lord, if they've been struggling or anything with that, Lord. Please give them wisdom and strength through whatever situation they're going through. Please help the school. As Monday we plan on allowing everyone to come back, Lord, to continue to give us safety. We assumed that this kind of wave was going to come by sooner or later, Lord. Thankfully it happened the time it did, so we didn't miss too much school, Lord. But please help us to be able to continue to stay safe and for it to just be a little awakener, Lord, so we know, hey, we got to be more cautious at school. We got to make sure our masks are on. We got to make sure we stay in the other classrooms. Please help us be able to do better at that in all the classes, Lord, certainly the younger ones. Please bless these 11th and 12th graders, Lord, as some of them are they're already thinking about their future, Lord, what they want to do. Please help me, as I only have the seniors for 1 year, Lord, for me to be able to have some kind of impact, whether small or big. Please allow me to be able to help them with something for their life. Please help this government class as our lesson today for us to be able to get through it quickly and so we can finish homework maybe during class. Bless this day, bless the students. Please help any prayer requests they might have, unspokens or special prayer requests. I lift up the ones I do remember, Lord. Please help Kylie's grandmother, I believe, Lord, with struggling with cancer. Please help her with that situation. Hopefully she's getting better. I haven't got an update in a little while, Lord. We're praying for that. Please help the family through the situation. Also Emma and her grandfather with a similar situation. Please bless the family in that. Heal him. Allow him to get better quickly. And also please help her uncle with the situation he's in. Bless all students. Please help us have a great class. In Jesus' name we pray. Amen. All right, hopefully you guys are here. And we're going to jump right into our lesson. Okay, today we are starting on page 147. Page 147. Okay, we talked about Some things yesterday with the procedure in appeal courts, kind of how it works with the civil and criminal cases, everything dealing with that. We ended with talking about precedents and how a little bit how an appeal court does not retry the case. They determine whether the lower court has followed the law or not. Put this here up on your screen. Okay, so we just a quick review with that. We talked about rules of evidence, how there are rules. If you find evidence or use evidence, but it was against the rules or policy, okay, then it won't really count. It won't really mean anything with that. Okay, but we're going to jump right in where we left off, talking about the Supreme Court. Okay, above all state and federal courts stands the Supreme Court, the highest tribunal of the United States. Okay, so you have the Supreme Court, the highest tribunal of the United States. It stands above all state and federal courts. Make sure you guys throw your name again for this class to be marked as present. It's a little bit past the time, but that's okay. Throw your name in now so I can know you're here, because we are missing quite a few people. Okay. Although the existence is mandated by Article 3, Section 1, which is the one we've been talking about this whole chapter, of the Constitution, the Supreme Court is at the mercy of the Congress in some aspects. For example, Congress determines how many justices will serve on the Supreme Court bench. Okay, since 1869, the court had 8 associate justices in addition to the Chief Justice. Thank you, Esther, Tori, Ian, Jake, Grace, everyone tuning in. Is the mic working any better today? I know I've asked that a couple times. Just seeing if the mic's working any better. Or not really. Okay, Noah, good to see you. Hopefully you're doing well. Okay, but continue with this. Again, the date, 1869, the court had 8 associate justices in addition, so really 9, to the Chief Justice. Currently, the justices grant full review in about 100 to 10,000 cases that are filed before the court each year. What's up, Jaylene? Good to see you're on as well. Kylie, Ellie, good to see you all. Thanks for tuning in. Okay, the Supreme Court possesses both original, the right to hear cases, and appellate, which is the right to review cases or jurisdiction. So basically, the Supreme Court possessed both original and appellate jurisdiction. Article 3, Section 2 of the Constitution grants the Supreme Court original jurisdiction in 2 types of cases. Okay, 2 types of cases. Those involving ambassadors and other diplomats, and those involving state. Its appellate jurisdiction extends to cases coming from the highest state courts or from the federal appellate courts. Very few of the cases that the court hears are the original jurisdiction cases. The vast majority of the Supreme Court cases come from the state courts of last resort or from lower federal courts through either appeal or petition. So within this Supreme Court, we also will see a few different things in terms and people. For examples for us, the Supreme Court serves as the interpreter of the Constitution and the final arbiter in cases involving constitutional questions. It is the right to interpret the law stems primarily from the power of the term we know as judicial review. Judicial review is the right of the court to declare a law or the action based upon the law unconstitutional. What's up, Emma and Christian? Good to see you guys here. Subpar. Hopefully it's better than the other one. Okay, but with this justice review, okay, we see this man, Chief Justice. Give you guys a couple more seconds to write this down in case I'm going too fast. Okay, we're going to see this man, or he was a Chief Justice. John Marshall. Chief Justice John Marshall. He asserted for the court the right of judicial review in the Marbury versus Madison in 1803. Okay, he was the Chief Justice that asserted for the court the right of judicial review in the court case Marbury versus Madison in 1803. Okay, you want to know John Marshall and you want to know that case, Marbury and Madison. Okay, Marshall wrote the following for the court. It is emphatically the province and duty of the judicial department to say what the law is. A law repugnant to the Constitution is void or has no meaning. Okay, that's what Marshall said or wrote to the court with this judicial review and to John Marshall. Okay, the Marbury case came about when President John Adams lost his re-election bid for the presidency to Thomas Jefferson in 1800s. Knowing that within a few days the Congress and the presidency would be overrun with Democratic and Republicans. Okay, Adams sought to pack the judiciary positions that would require more judges. Okay, therefore, the still Federalist Congress created several new judgeships prior to Jefferson's becoming president. John Adams appointed judges to the newly created offices, and the Senate confirmed those appointments. And John Adams signed their commissions, a document that authorized their appointment. Okay, Adams gave the commission to the Secretary of State, John Marshall, to deliver. By the time the Federalists left office, Marshall had delivered all but 17 of the commissions. The undelivered commissions were left for the incoming Secretary of State, which was James Madison, to deliver. When the new president, Thomas Jefferson, heard about Adams' midnight appointments, he ordered Madison not to deliver the remainder of the Federalist commissions written by the predecessor before. Okay, William Marbury was one of the men whose commissions was withheld. He had been appointed by John Adams to serve as the justice for the peace for the District of Columbia. Upon hearing that his commission was being withheld, Marbury, along with 3 other men, hired a lawyer and brought a lawsuit against Madison. Specifically, the lawsuit requested that the Supreme Court issue a right of mandamus, okay, or a writ of mandamus, which is a court order compelling a person to obey. Okay, with this writ of mandamus, a court order compelling a person to obey. Okay, it was a power given to the Supreme Court by the Judiciary Act of 1789. Okay, such a writ, okay, by the court would force Madison to deliver the commissions to Marbury and the others. Okay, he would not withhold it anymore. He had to deliver it by law. In the ensuing cases, Chief Justice John Marshall, formerly President Adams' Secretary of State, ruled that James Madison should have delivered the commissions to Marbury and the other appointees. However, Marshall also said that the Supreme Court did not have the power to compel Madison to deliver the commission because the part of the Judiciary Act which granted to the Supreme Court the power of writ of mandamus was unconstitutional. By stating that Congress did not have the power to give the court the writ of mandamus, Marshall gave the court the right of having the final say on the constitutional matters. Although the Constitution definitely makes the legislative and executive branches superior to the judicial branch, okay, we see that the supreme, or the power of the judicial review, gives the Supreme Court its most important tool in checking and balancing Congress and the president. Okay, with this, the principal ways, so we're going to see the legal road of the Supreme Court, since they're there to check, to keep the Congress and president in check. Okay, we're going to see the principal ways by which cases reach the Supreme Court are on an appeal. As the matter of right, or the writ of certiorari. Okay, so there's two terms you need to know in there: appeal and the writ of certiorari. Okay, the Latin word for writ means made more certain, okay, which is the petition for the court to hear a case. One who appeals a case is called an appellant. I'll give you guys a little bit of time to write down note number 40. Sadly, we do know once you're on, and then if you get off, because we only have 8 viewers now. So make sure you're still paying attention, because if you miss something and then you don't turn it in, it is on you, and you will receive a 0. Okay, so one who appeals a case is called an appellant. Okay, most cases which are appealed as a matter of right are rejected for want of a substantial federal question or on other jurisdictional grounds. Since 1988, the Supreme Court has been given most or almost complete control over deciding which cases it will hear. This power to decide whether it will hear a case or not is called discretionary review, which is already on this note as well. Discretionary review is the power to decide whether it will hear a case or not, and that one was also in your homework, so you should be familiar a little bit with that term. Okay, most of the cases, hopefully you guys are done with this one. I'm going to go to the next note. Note number 43, how does a case get to the U.S. Supreme Court? Okay, we've already talked about all of the basically steps, but the 3 main steps is you have an original jurisdiction, okay, of this case, you have an appeal of the case, and then you have a petition for the case to get presented to the Supreme Court. Okay, those are just the 3 main steps, or how a case gets to the Supreme Court. Give you guys time to write that down. Fix this camera. Not still. Oh, it's this thing. There you go. There we go. It's like a little black blur. It's plastic. Okay, moving on. Note number 44. Most of these cases, or most of the cases which are actually decided by the Supreme Court, come to the court by means of discretionary writ of certiorari, or cert, okay, which is the petition for the court to hear a case. Some of these notes are a little bit longer, so I'll try to give you guys a little bit of time to write them down. Okay, note number 45, dealing with these cases and the writ of certiorari. Okay, in all cases involving a substantial federal question in which the right of appeal does not exist, the party sustaining an adverse decision from the lower court has the privilege of petitioning the Supreme Court for certiorari. So you want to know the term petitioner. I know these ones are a little bit longer, so I'm trying to give you a little bit more time to write it down. Okay, we're going to be moving forward into the court in session a little bit. Okay, the court can decide the court can decide whether or not to grant a petition without starting the reason to the petitioner. Okay, again, you will be marked as late, Victoria, as it is late. Okay, remember I said on Wednesday it has to be in the first 10 minutes of class. Okay, for the court to hear a case, 4 of the 9 justices have to agree to grant the petition of the case. Obviously, not all petitions for the writs of certiorari are granted. We've talked about this. Indeed, the Supreme Court agrees to review only about 2% of the large volume of cases coming to it on the petition for the writ of certiorari. Okay, so we're going to be moving on into the court of session. Okay, the Supreme Court sits for approximately 9 months each year, from the first Monday in October until the end of June, or perhaps sometimes longer. This 36-week term is divided between the hearing of cases and their intervening recesses for consideration of the business before the court and the writing of opinions. Opinions are delivered by the assembled court on Tuesday and Wednesday when the court is hearing oral arguments. Okay, so basically moving on. Okay, we just need to know a few terms with this. Okay, you can do some of the reading in your homework. Okay, but that's the process of the court in session. But someone that petitions, or one who petitions a court to review something, is called a litigant. A litigant, okay, is one who petitions a court to review the decision of a lower court. Okay, this brings us to note number 47, which I've already mentioned. The Supreme Court sits for the first Monday in October until the end of June, a 36-week term. A 36-week term. I know there's some different terms in here, a little bit more difficult to remember and spell. Okay, so you got to do your best to remember what they are and what they mean. 2 different writs. Okay, this is going to bring us to a time. Okay, we have opening ceremony in a court session. At the sound of the gavel, all in the courtroom, including the justices, arise and remain standing until the completion of the crier's chant. Okay, so this is what's going to be said when a court is opening. Everyone rises. Okay, then these words are said, and then everyone, well, not everyone, but most people may be seated. Okay, the Honorable, the Chief Justice and Associate Justice of the Supreme Court of the United States. Oh yes, oh yes, oh yes, all persons having business before the Honorable, the Supreme Court of the United States, are admonished to draw near and give their attention, for the court is now sitting. God save the United States of this honorable court. Okay, that is the crier's chant. That is announced in these opening ceremonies of the court in session. Okay, that's going to move us along to oral arguments. Oral arguments are normally heard Monday through Wednesday during 2 weeks of each month. When the court hears the oral arguments in a case, the justices have already had the opportunity to study the major points of the case. Copies of the brief are filed, remember we talked about briefs, okay, are filed with the court well in advance of the formal courtroom hearing date. In addition to the materials filed with the court by the opposing attorneys in a case, we have the amicus curiae. The amicus, curiae. Okay, this is a friend of the court. It means friend of the court. You'll want to know that. Okay, this is where briefs filed by individuals who are not parties in the case but still have an interest in the case outcome. Okay, so they're friend of the court. They don't really have a party of either side, but they do have an interest in the outcome of the case. Okay, as we have a few more minutes left, we're going to try to get through these notes quickly. Okay, note number 49, conference handshake. This is a custom that serves to remind all the justices that difference of opinion do not, preclude harmony of purpose. Don't think there's supposed to be a period there, but I'll leave it for now. Okay, so no, that's a conference handshake. Sorry, as I'm going to speed up a little bit just so we can get through all these notes. Again, I would either underline them in your book, highlight them in your book, put the number by in your book. Okay, note number 50, unanimous opinion is where if all justices agree on a case. Unanimous opinion, pretty common sense. If everyone has the same opinion, unanimous. Okay, it's where they all agree on a case. Okay, while justices tend to be independent and confident in their own ideas, it is not uncommon for all 9 justices to agree on a case. About 33% of the decisions are unanimous. If the court is split on a case, it issues a majority opinion, or also known as court opinion. Majority opinion is also known as the court opinion. This is where if the court is split on a case. The court is split on a case. A controversial case may produce several concurring opinions. Any justice who does not vote with the majority on a case may write a dissenting opinion, which is where they're explaining his reasons for disagreeing. Okay, so those people that aren't part of the majority, when you have a majority case, okay, they will make a thing called dissenting opinion. You have concurring opinion, which is if a justice votes with a majority but wishes to explain his reasoning in a separate opinion. Okay, then you have dissenting opinion when a justice does not vote with the majority on a case. Know the difference between the two. Concurring opinion, it's when they vote on the case or with majority but wish to explain his reasoning in a separate opinion. Okay, he votes with majority just to get the vote through, but he's like, hey, this is my difference in our situation. Okay, I have a different opinion about this. Okay, dissenting opinion, this is when a justice does not vote with the majority of a case. Okay, this will lead us to something that's called the opinion day. Even though a vote has been taken on each case during the conference, any member of the court can reverse his position at any time before this special day called opinion day. Opinion day is the final opportunity for a justice to reverse his position. It is the final stage of the Supreme Court's decision-making process. Just like there's a general election day, last day to vote. Okay, you also have this in court called opinion day. Okay, a few more notes. We're going to, again, try to get through these quickly. Okay, note number 55, the oral presentation of the judicial opinions is a characteristic mark of the U.S. Supreme Court. The oral presentation of the judicial opinions is a characteristic mark of the U.S. Supreme Court. But there are restraints and changing roles in the Supreme Court and in this process of the judicial branch. Okay, there's a thing called judicial restraint. Okay, this is an idea or philosophy that judges apply the law according to the original understanding of the men who wrote the Constitution and those who ratified it. Okay, you don't want to know the difference between this, judicial restraint. Give you guys a few seconds to write this down. And then we have what's called a judicial activism, which is another idea or belief that judges should go beyond the four corners of the Constitution to change societal behavior. To change societal behavior. Okay, and our last note for the day, we have note number 58. Okay, with these two different ideas, okay, although we see this time where we see both these things going on, those who are judicial activists tend to dismiss those who hold the restraint view by saying that the Constitution is dated and that unless judges have broad latitude in interpreting the document, it will not serve society as well. However, the framers considered the dated nature of the document when they wrote the Constitution. Article 5 is devoted to the method of amending the document. Changing the Constitution by amendment is the most honest means of altering the document if it is dated. To change the Constitution other than by amendment is to subject American citizens to rule by judges rather than to rule by law. Okay, so we're going to see a time it's called the Warren Courts, happened for about 13 years or 16 years, began the activist tradition. The court under Chief Justice Warren Burger made more revolutionary decisions. On January 22nd, 1973, in Roe v. Wade. Roe v. Wade. This is where we see declared unconstitutional a Texas law and the laws of 45 other states. Okay, that had made elective abortions criminal offenses except when performed to protect a woman's life or death. Okay, obviously this is elective abortions is deliberately killing unborn children. Okay, ignoring 3,500 years of Judeo-Christian civilization, religion, morality, and law, the Burger Court held that an unborn child was not a living person, okay, but rather the property of the mother. And I know some people will disagree, and obviously we see that into our day even more now. Okay, but this was a problem even back then. Okay, but now it's even more saying, is it real life or is it just property of the mother? Okay, obviously there's difference in opinions, but we see in the Bible how it teaches us it is part of the mother. It's not just property of the mother, it is part of the mother. It is its own life inside of her. Okay, so we see these different terms. And in the book, page 154 is continuing in that story in different cases dealing with that. Okay, if you guys would like to read that, you can. But for homework tonight, okay, you should have done questions 1 through 5 last night, but homework tonight is page 154, questions 6 through 10. Page 154, questions 6 through 10. Okay, I want to be kind to you guys because I know this distant learning is a little bit harder. On Monday, okay, we were gonna have a quiz on Monday, but on Monday we're gonna review for our quiz over this chapter. Okay, so we're gonna start the next chapter, but we're gonna review after we're doing the beginning of next chapter. We're gonna review for this chapter, okay, and for our quiz, and then Tuesday we will have a quiz over chapter 8. Okay, be ready for that. If you guys have any questions, let me know. Again, homework is page 154, questions 6 through 10. If you have questions, let me know. Class is dismissed. You guys will have class next hour, I believe, on the same stream. Okay, I don't think you have to change anything this time that I know of. I think Mr. S is here today. I saw him here at least. Maybe he went back home. I do not know. Also, as of right now, you guys will be returning, if you did not know already, on Monday. Okay, so let your parents know. There's probably going to be an email going to your parents, but you will be returning to school on Monday if you would like. Okay, if you're not going to, so say, hey, my parents don't really feel comfortable yet, or I'm still sick. Okay, you need to communicate to me. Okay, not through the chat, but to me. So I know for my classes, okay, I have another distant learner, so I can get you everything you need. Let me know. Hopefully you guys are doing well. If you have any questions, again, let me know. You have to communicate. We will see you, Lord willing, on Monday. Have a good day.
All right, welcome to chemistry. It's good to be back here. I look forward to seeing you guys back on Monday. Hopefully you guys can see and hear me okay. As far as seeing me, I shouldn't be a problem, but hopefully you guys can hear me okay. We are aware of the audio issues. Every time I think I've got it fixed, it'll work for about a week, and then it comes back. So not really sure what's going on, even went so far as replacing his mic, and I'm just at the point now where we're just going to have to replace the tower. So I do apologize for that. We are aware. I'm trying to fix it. So hopefully next week things should be better. I'm at a loss. I've never had this much problem figuring out what's going on a computer. So not sure what's going on, other than I think we're just asking too much of this poor processor. Anyway, so we're going to get right into it. We are in chemistry. We are on page 80 of our supplements, page 65 of our textbook. So go to page 85 of your supplement, page 65 of your textbook. Again, we'll be doing both things. And so here we go. In the 1600s and 1700s, scientists discovered that gases behave in orderly ways and can often be described by precise mathematical relationships. In this section, we will discuss and explain the gas laws from the standpoint of the kinetic theory. Never fails. I cannot touch these glasses at all, and they'll still be smudged. All right. Let's see here. Remember, however, that the gas laws were experimentally derived first without a theory to account for gas behavior. The kinetic theory of matter was developed later to explain these gas laws. So we know these gas laws for a fact. That's very much a thing we know. We proved these experimentally. And then from there, we developed the kinetic theory of matter to help explain what's happening. Might be the only one that's bugging, but it's slightly crooked. Okay. Like the kinetic theory, the gas laws describe the behavior of an ideal gas. Real gases do not adhere exactly to the gas laws we shall study, though under many conditions they do adhere quite well. Though no real gas is ideal, we shall assume ideal behavior in our further discussion of gas laws. That gas behavior under most normal conditions can be described by simple mathematical relationship shows evidence of the design and order that God has placed in creation. Relationships between particles of matter are not haphazard, rather they can be described by reproducible mathematical equations. And that's not something to take for granted. The reason why that's so key, and this is just something about anything science, the study of science in general has to assume the existence of a higher power to begin with. It has to assume a constancy. It has to assume a consistency. That wouldn't be there if we were brought about by chance. You can't be brought about by chance and then suddenly have very strict thermodynamic and physical laws. It's just not how that works at all. So just mentioning that there. With that, so that's just a great way to look at this. So one of the first ones to be discovered was Boyle's law, found by Robert Boyle. There we go. I was looking for his first name. And it's when we compare volume and pressure. And so because a gas is compressible, its volume is not constant when it is squeezed by increased pressure. Rather, the increased pressure causes the gas to shrink. Reducing the pressure on a gas, on the other hand, causes the gas to expand. So for example, if we had some gas trapped at the end of a tube, and as we add mercury, you'll notice it gets more compressed. Okay, that's not a vacuum there, that is a gas, and so it gets more and more compressed as we add more materials. The first careful research about the relationship between volume and pressure was done in the 1660s by Anglo-Irish scientist Robert Boyle. In his experiments, Boyle used mercury to trap a small amount of air in the glass tube shaped like the letter J, and with the end of the short stem sealed and the end of the long stem open. When Boyle poured mercury into the open end of the tube, the bend in the tube trapped a small volume of air in the short stem and formed columns of mercury on each side of the bend. The pressure on the trapped air could be calculated by measuring the difference in heights of the mercury columns, delta H, and adding the pressure due to the atmosphere. Addition of mercury to the tube would increase delta H in the pressure, thereby decreasing the volume of the trapped gas. And so That's a very important thing, is that as we add pressure, the volume decreases. This is why air in brake lines can be such a problem. Let me switch back to this. Air in brake lines can be such a problem because it's compressible. Brake fluid is used instead of a solid because, like a solid, a fluid is incompressible. So the force that you transfer through it will make it to the other end, no problem. So we'll use it because it's a lot easier to get flexible tubing through your car than it is to have a system of steel rods, although we could. And I think we did at some point. But anyway, moving on. I think that's how we started and then figured out we could use fluid to do the same thing. Don't quote me on that, though. Not an automotive person. But with that, okay, if an air bubble gets trapped in the brake line, well, then your brakes suddenly become very spongy and they don't effectively push the force, because instead of transferring the force along the line, a gas will just compress and the air bubble will become smaller as you press on the brake pedal. And that's why that can be such a big deal. That's why service manuals will actually tell you, do not mess with your brake system. Make sure a trained professional does it, because they have to make sure that there's no air bubbles on the line. That's more than a little required. Now, plots of volume versus pressure and volume versus 1 over pressure reveal an inverse relationship between pressure and volume. Represented by V is proportional to 1 over P. The results of Boyle's experiments can be summarized in what is called Boyle's law. At a constant temperature for a given amount of gas, volume varies inversely with pressure, or mathematically 5.3 there. Okay? So as pressure increases, volume will decrease. As pressure decreases, volume will increase. Okay? It's an inverse temperature. Now you'll notice temperature is not in the scale here. There's no T, there's no anything else that we could use for the measurement of temperature. And so this assumes that the temperature hasn't changed during your experiment. In the previous experiment with the mercury and the J-tube, it would be reasonable to assume temperature didn't change of the gas during that time period because it was near instantaneous. The experiment was very short. Okay, so it's relatively solid to go ahead and assume that. Now K is just used as our constant as long as the amount and temperature of the gas sample do not vary. The inverse proportion may be observed and explained in terms of the kinetic theory of matter. If the volume occupied by a given amount of gas is decreased to 1/2, the space between molecules is halved. This causes gas molecules to collide with each other and with vessel walls twice as often. Twice as many total collisions per unit time amounts to twice the force per unit area, or twice the pressure. There we go. So as we bring this down here, okay, you can see we're shrinking the volume. So as we double the pressure, we have the volume, okay? And so if we double it again, then we have the volume again. Twice as many total collisions per unit time amounts to twice the force per unit area, or twice the pressure. Thus, as volume is halved, the pressure is doubled, and so on. For a given amount of gas at a given temperature, the product PV is constant, as shown here by equation 3. If either variable changes, the other must also change in such a way that the product PV remains the same. So we can state Boyle's law in the way of equation 5.4, where P1V1 is equal to P2V2. In other words, before the experiment, the initial pressure and volume are known. And then I'm going to change one, I can find the other, okay? Because these two quantities, when multiplied, must be constant because we're not changing anything else. This equation can be used to solve problems in which gases change in pressure or volume by solving for the desired quantity. An easy way to remember equation 5.4 is simply keep in mind that the inverse relationship between pressure and volume means the product is constant, and this is demonstrated in the following example. A flexible helium-filled weather balloon has a volume of 500 liters at a pressure of 1 atmosphere. What will be the volume of this balloon, when it reaches an altitude at which the pressure is only 0.5 atmospheres? And we're going to assume constant temperature, okay? Which actually, that one's not completely reasonable to assume. Temperature drops as you increase elevation. If you don't believe me, just climb a mountain. I say just climbing a mountain. You get my point. You'll notice it's much cooler at top than at the bottom. But we're assuming the temperature here is equal for some bizarre reason because, you know, math. All right, so we're going to start out with, and it's doing it again. It was working fine before class. All right. This thing only has to make it a little longer. Let's try this again. Nope, still doing it. Why? Sorry, this is really weird. My tablet is not wanting to, like, use the whole tablet. All right, well, I may just have to show you guys the pre-done math because this is not working no matter what I do. That's fun. Okay, so maybe now? All right, there we go. I don't know what just happened there, but all right. So here we go. We know we're going to use the equation P1V1 is equal to P2V2, okay? And so with that, let's look at what we have. We have our initial situation. We have 500 liters. This is volume 1 at a pressure of 1 atmosphere, so this is going to be pressure 1. Here, then, this will be pressure 2, because atmospheres is pressure, and so we're looking for V2. That's the goal here. So we're going to divide both sides by P2, and then rearrange the equation. So V2 is going to equal to P1 V1 over V2. All we've, nope, P2. Why does undo not work? Okay. And so we just plug in. P1 is 1 atmosphere. We have volume of 500 liters. And we have a second pressure of half an atmosphere. Blech. All right, well, if we take 500 and divide it by 0.5, we're actually multiplying by 2, and we find out that it's about 1,000 liters. Okay? And so that's all we're doing here, is we can find the new volume, which is very important. And so if you've ever noticed a high altitude weather balloon, you'll notice they send it up and it's only maybe half inflated. And it almost looks a little weird. Well, that's because it's going to double the amount of space that gas takes up the further up it goes in the atmosphere. So they have to leave it plenty of room to expand so that way it can get to the altitude it needs to get to without popping. Basically is the idea there. All right, there's the nicer version there. And I will give you guys just a minute. All right, so that's Boyle's law, and yes, you do need to know the name of which one's which. Okay, now you can put it on your 3x5 card for all I care, but you need to know Boyle's law is P1V1 equals P2V2. That's the form we use anyway. And with that, okay, in addition to Boyle's law, we have Charles's law, which deals with volume and temperature. And so basically what happens here is volume and temperature are directly proportional, okay, to the absolute temperature. Okay, and so as you look at this, as we heat up a sample of gas, okay, as we increase the heat, it will expand the gas, and as we double the heat, it will double the volume, and if we double the heat again, it will double the volume again. Okay, they are not quite doubling there, but here we're going to double it from the second time. And so each time we heat it up, we're going to actually expand the gas within. So this experiment took place around the year 1800. Jacques Charles and Joseph Gay-Lussac studied the effect of temperature on the volume of gas. You may be familiar with the effect temperature has on the volume of a balloon. Placed in a warm place, the volume may increase so much that the balloon bursts. Suppose we have 273 milliliters of helium gas at 0 degrees Celsius. If the pressure is constant, we would find that the volume of gas increases by 1 milliliter for every 1 degree Celsius rise in temperature. That is, the volume increases by 273rd of its volume for every degree Celsius rise in temperature. At 2 degrees Celsius, the volume will be 275 milliliters. At 10, 283 milliliters, and so on. A further study showed that though the volume varied with temperature in a regular manner, the change was not proportional to Celsius temperature. Only when Celsius temperature was converted to an absolute temperature scale, such as Kelvin scale, was the volume directly proportional to temperature. Thus, excuse me, when working with relationships between temperature and volume, you must convert Celsius to an absolute scale, which is Kelvin. You have to use Kelvin or this equation doesn't work. Anytime you see T in this entire chapter, it must be in Kelvin. Okay, you may not use Celsius, and you certainly better not use Fahrenheit. Okay, mostly because Fahrenheit is useless, but we're moving on. In science, anyway. Okay, I actually prefer Fahrenheit for day to day. With that, you have to use the Kelvin scale. It's not good enough for it to be in Celsius. You notice in atmospheric pressure, as long as we keep our units the same, everything's fine. In temperature, it must be in Kelvin or it will not work. Okay, and so we derive this equation here. This is Charles's law. Written out, it's the volume of a given amount of gas at constant pressure is directly proportional to the absolute temperature. Now, this strictly holds only for an ideal gas at constant pressure, but many gases follow it quite well over a range of temperatures. If you look in your textbook on page 67, you'll see a chart where they plotted volume versus temperature. And essentially what would happen if we could keep something a gas all the way down to absolute zero, which is not possible, but just humor me for a minute. If we were able to keep something a gas all the way down to absolute zero, then it would end up with a zero volume. That's why that's where it's needed to be proportional, because we have to go down to absolute zero in order to get that proportionality correct. And so we have to use Kelvin. The reality of it is, and this one in particular is a plot of nitrogen. Obviously, nitrogen at some point is just going to condense before we get down to absolute zero. So nothing ever actually attains a zero volume, but we can get very close to it. And that's what would happen if something were able to stay a gas, but nothing that has been observed can be a gas at 0 degrees, 0 Kelvin, there's no degrees, at 0 Kelvin, and therefore nothing can end up with a zero volume, so we don't accidentally break any laws of physics. Now again, remember, Charles's law applies only to gases. So once you're out of that phase, you can no longer apply this law. All right, let's look at an example of how we use Charles's law. We have V1 over T1 equals V2 over T2. And let's look at, I had the chart in here. Okay, so this is my point. What would happen, the theoretical volume would go down to zero, but again, nothing exists as a gas at absolute zero. So even nitrogen, which gets pretty far, at some point will condense down to a liquid and actually solidify before absolute zero. A balloon has a volume of, so on to the example, a balloon has a volume of 1,000 milliliters at 300 Kelvin. If it is placed in a lab freezer with a temperature of 200 Kelvin, what will its new volume be? Okay, so we have an initial situation and a final situation, so let's go through and analyze this. So we have an initial volume, so V1 of 1,000 milliliters. That's exactly 1 liter if you'll notice. And then we have an initial temperature of 300 Kelvin. We are given a second temperature and we're told to find a new volume, which is typically what we want to know in a situation like this. And so we're going to start out with our equation of V1 over T1 equals V2 over T2. And I'm looking for V2, so we're going to multiply both sides by T2. And so when I do that and rearrange, V2 will equal V1 T2 all over T1, and then we can plug in. Okay, so V1 is 1,000 milliliters at 300, nope, we're going to go to 200 Kelvin. Notice we have V2 on top, or sorry, T2 on top. So we have 200 Kelvin up here, and we have 300 Kelvin down here. So Kelvin cancels, and we end up with, it's going to end up being 2/3 the volume, and so it's going to be about 667 milliliters. Okay, so that's how we do that. Here is the nicer looking version of that, but I like handwriting it because then you can see where everything's coming from. And this is basically all we do, is we just rearrange for the piece we need and plug in and go. Okay, so the gas laws are actually pretty simple. The issue is making sure that you keep which one is which correct. Yes, good question in chat there about balloons popping when they're let go. The reason why they do pop when they get up into the atmosphere is there becomes less pressure around the balloon. So this actually has less to do with temperature, although I'm sure that plays a role in it. It has less to do with temperature and more to do with pressure. As there's less pressure on the gas, on the outside of it, the volume is freer to expand, and eventually the balloon will pop because the latex can't take it anymore, or whatever material it might be. So what's actually happening there, more than anything, is actually a decrease in atmospheric pressure around the balloon. So the balloon is more free to expand based on the pressure inside, and then it goes. All right, I'm going to cover one more piece today, and then I'm going to pause until next week, and then I'll make some announcements here at the end. But I'm going to cover one more little bit because we can actually combine Boyle's law and Charles's law into, creatively named, the combined gas law. Okay, we have the combined gas law, which deals with volume, pressure, and temperature. And you'll notice it's basically as if we mashed the two equations together, and that's exactly basically what happened. And so with this, one thing to note here, very quickly, is that if temperature is constant, notice that they'll just cancel out of the proportion, and you're left with Boyle's law. If we were to keep pressure constant throughout, we would have Charles's law. So what they actually did is they actually both just found pieces of the combined gas law, okay? Because if you hold one constant, the other two will change normally. So here's what I normally do. I memorize this one, aside from the one that I need to fill in the blanks or whatever, or know which one's which. I just use this one all the time, and if something's constant, I just cancel it out of the proportion, okay? Because then I don't have to remember what's where, which one's division, which one's multiplication. That's personally what I do, but I'm also kind of a math person. So that's just food for thought. You can do that if that's how your brain works. Really quick note, when solving problems using the gas laws, only the initial and the final conditions matter. That's it. The path you take to get there is irrelevant. Okay? It's irrelevant which one changed first, too. We don't have to worry about did the pressure change first, did the temperature change first. All we need to know is what changes happened. Let's account for them. That's it. That's all you have to do. All right? There is a phrase we will use quite frequently throughout the remainder of this text, and that is standard temperature and pressure. This is an agreed upon set of conditions that is considered standard for the sake of figuring this out. We define it as 0 degrees Celsius, which is actually 273.15 Kelvin. For this class, we're going to stick with 273 Kelvin, so it's a whole number, and 1 atmosphere. Again, 1 atmosphere is 760 torr. Okay? And the only reason why we just round or ignore the 0.15 for the Kelvin is for ease of calculation. It just makes the math a little easier. And so, again, this is a high school chemistry class, not, learning to develop medications and things like that. So this is fine. All right, so that's anytime we use standard temperature and pressure, or you'll see it abbreviated as STP, this is what we mean. It has to be at 0 degrees Celsius, 1 atmosphere. Okay, specifically 273 Kelvin, because that's what we have to use, and 1 atmosphere, or 760 torr if we're given torr. If we need pascals, we can look up what 1 atmosphere is in pascals, and so on. Okay? And so with this, a sample of methane gas occupies 5 liters at 730 torr and 27 degrees Celsius. What volume will it occupy at 1 atmosphere when cooled to the temperature of dry ice, which is negative 78 degrees Celsius? Okay, so first thing we need to do before we do anything else, and actually I'm just going to show the math on here. I think it's pretty self-explanatory what we're doing, but I'll highlight things as we go. The first thing we need to do, what are we given? Well, we're given Celsius. We're not allowed to use Celsius. We have to convert them to Kelvin first. And so if you'll remember, to convert Celsius to Kelvin, you just add 273.15. Again, we're only using 3 significant figures here for the sake of calculation. So we're going to use the unrounded answers in our calculation, but basically that's all we're worried about. So it's about 300 Kelvin and 195 Kelvin. Okay. So that's the first step, is we have to transfer the temperature to Kelvin. Then we set up using our combined gas laws. And so P1 will be 730 torr because that's our first pressure. V1 will be 5 liters, and T1 will be 300 Kelvin because we were told it's at 27 degrees Celsius. Now we're trying to figure out the volume, so V2 we won't know. That's what we're going to actually rearrange the equation for. We know P2 is going to be 760 torr. And the reason why we're using the torr measurement is because we're using the torr measurement on the other side of the equation. So you have to stay in the same units on pressure. Past that, it doesn't matter which one you're using as long as they're the same one. And then the temperature too is 195 Kelvin. And so we'll go ahead and rearrange. We're just multiplying both sides by the reciprocal of P2 over T2. So we're basically taking this and saying, all right, I'm going to multiply this by T2 over P2. Take this and multiply by T2 over P2, and you can see the remains of that right there. The whole reason for that is just we're solving for V2, okay? And we just are multiplying by the reciprocal to rearrange the equation. All right, so we're going to go ahead and plug in. We have 730 torr times 5 liters times 195 Kelvin, all over 300 Kelvin and 160 torr, or 760 torr. And notice again, the torrs are going to cancel, Kelvins are going to cancel, and we're going to be left with liters, which is exactly what we expect, seeing this is volume. Okay? We throw all that mess in our calculator, and we get it's about 3.12 liters. So with that combined gas law, we can actually do quite a bit. Okay, I'm going to stop right there. For this week. I know it's a bit early yet for me to stop. Not that you guys would ever complain about me ending class early. Whoops. That's why. Yes, okay. Because we're not supposed to actually get out until 10:50, but that's okay. You guys can get a little bit of an extra break here. So basically, a couple things going on here. First of all, notice that we are quite a ways into Chapter 5. So don't be ignoring your Chapter 5 homework just because we haven't taken the previous test. Make sure that you guys are working on it, because the Chapter 5 homework and quiz is going to be coming up on you faster probably than you're expecting. I'm not trying to overburden you with stuff, but at the same time, we have to get stuff done, so that's the idea. Keep in mind, you have Test 4 over Chapters 3 and 4, 10.1 through 10.4 as well, on Monday, Tuesday, when you guys get back, with the grace of you guys have it as open book, open supplement, okay? Because a lot's happened in the last few weeks. So I'm gonna give that to you guys as an open book test. So you guys don't have to super cram for it or anything like that. Just make sure you're familiar with the concepts, maybe glance through things along those lines. Again, if you will not be present in class on Monday, I need you to please email me today by 3 o'clock so that way I can set up your account so that way you can take your test at home, okay? It's open book and things like that, but I have to get you all set up because it's not as simple as I can email you a paper copy. That's just not how that works. So that's what we're going to do there. So I look forward to seeing you guys on Monday, but you guys will have that right away. But again, it's open book, open supplement. Should be a little simpler on you, and we'll continue lecturing on this topic on Wednesday of next week. and continue on there with chapter 5. All right. I will see you guys Monday in person. We are resuming in-person classes on Monday. So again, if you're not going to be here, and you're not a distance learner, okay? If you're a distance learner, I already have you set up. But if you're not going to be here and you're not a distance learner normally, or you're just now transitioning to distance learning, please let me know as soon as possible. I only have 3 people that I know for sure are distance learners. So if any of you are going to be out on Monday, I have to know. All right. Past that, that's where I'm going to end it because I don't want to overload you guys with material. I've already given you guys quite a bit. So I will see you guys next week.
right, guys. Okay. We're going to go ahead and get started today. We're going to be on section 6.3. That's page 144 in your books. Page 144. Using unit prices. After we find the unit price for different brands of equal quality and different sizes of the same brand have been determined, the savings per unit can be found by determining the difference between the unit prices. Okay, so we want to figure out how much we're going to save by buying the different quantities. We have model problem number 1 here. A 14-ounce bottle of ketchup costs $1.29. A 32-ounce bottle of the same brand costs $2.89. Which bottle is better buy, and what is the savings per ounce? Okay, so what we're going to do is we're going to figure out the better buy by figuring out the price per ounce. And for the 14-ounce bottle, we're going to have 9.2 cents. For the 32-ounce bottle, we're going to have 9 cents. So we're going to have a savings of 0.2 cents per ounce. And then problem number 2 here, we have Tracy was given the responsibility to purchase 4 12-ounce packages of spaghetti for a party. When she got to the store, she found that the 12-ounce package of spaghetti cost 55 cents, but bulk spaghetti of equivalent quality cost 47 cents per pound. Find the unit price per pound for 12-ounce pack of spaghetti. Find the savings per pound for bulk spaghetti. So what we have to do is we have to convert ounces into pounds, and we find that 12 ounces equals 0.75 pounds. So 55 cents times 0.75 is 73.3 cents. And we finish out that problem, and we come to find out that we're going to save 79 cents by buying in bulk rather than buying the individual packages. Okay, so a lot of times you can end up saving some money if you buy in bulk rather than buy individually packages, especially when you're buying a large quantity. Make sure you're doing that. Other than that, that is it for today. Let me look up the homework for tonight. Again, if you are normally going to be distance learning, you need to make sure you come pick up your lesson plans for this week for this class. They also have your tests and quizzes with it. If you're not normally distance learning, we will be back in school on Monday. So we will see you guys then. Homework for tonight is going to be page 145. And let's do the odd problems. Page 145, let's do the odd problems today. Again, we will see you guys on Monday. We're going to be back in school. If you are a normal distance learner, again, you need to make sure you come in and get your packet from me. It's going to be at the office after school today, and that will have your tests and quizzes with it as well. So I will see you guys on Monday, and that's it for today.
Hello, hopefully you guys can hear me. I just was trying to fix the mic, but today we just have our test and our quiz 5 worksheet that I just sent you guys. Let me know if you guys didn't get it. I sent it to your emails that you guys wrote down on that sheet, so hopefully you guys got it. But in the comments, let me know, well, number 1, let me know that you're here. And then number 2, let me know if you didn't get the assignment, okay? So, honestly, that's pretty much what we have for today. Just fill out your test. That's over units 1 through 3. And then your quiz 5 worksheet. Your quiz 5 worksheet you can turn in on Monday. That's tonight's homework. So that doesn't have to be, the quiz 5 worksheet doesn't have to be turned in today. That's for homework tonight for grammar. So that's practicing our sections that we went over. Section 9 over subject and verb agreement and pronoun and antecedent agreement. That's just for some extra practice. So you can go ahead and use your books for the grammar worksheet and then take your test over units 1 through 3 in literature today. And if you guys notice on the email that it says you need to take the test today and then send me a picture by the end of today. So either you can text me a picture of your completed test, or you can use the app Cam Scanner and then send it to me, or you can take a picture and email it to me, okay? My email is hannahcoral@calvarychristianonline.com, okay? Jake, I sent it to, let me look at the email that I sent it to. I sent it to kafarojake@gmail.com. So hopefully that's your email. If it's Kafaro, CAFAROJAKE @gmail.com. I sent it about 8 minutes ago, so hopefully you guys got it, but excuse me, let me know if you guys didn't, okay? But yes, honestly, that's all that we have for today. We just have the test. Like I said, take the test today. Send me a picture of it today, by the end of today. And then when you guys come back on Monday, I need the copy, the physical copy of the test, okay? So turn that in on Monday. Send me a picture today. The quiz 5 agreement worksheet is due on Monday. And then also due on Monday are your vocabulary definitions 1 through 12 2 times. So that is from list number 4, okay? So, or list or unit number 4, vocab and definitions 1 through 12 2 times. You can either text me a picture of that today or bring it in on Monday or send me an email. So if you guys have any questions, let me know in the comments. I'll be in the classroom, so if you have any questions, I can just type. Hopefully I can type back. Let me see if I can. Type back the comments. Okay, yes, I can type back. It says Calvary Christian School Banning 6th grade, but obviously this is 11th and 12th grade, but I'll be able to comment to you guys. So if you guys have a question, go ahead and type it. Other than that, today is the literature test. Excuse me, the literature test and the quiz 5 agreement. So if you have any questions, let me know. Other than that, you guys are dismissed for today. I see some of you guys who commented. Jake, Esther, Tori, Jaylene, Christian, Grace, Noah, Michelle, and Kylie. I think I'm missing Emma. And let's see, who else am I missing? Jaylene and Victoria and Ellie. So if for some reason they hop on here after, just let them know I sent them the quiz and the test. And then if they have any questions, just comment. And then, like I said, I'll try to get back to you if you guys have any questions, okay? Thanks, guys.
All right, welcome to Algebra 2. Let's go and get started. We're on 3.4 polynomial inequalities. We are on page 139, page 139 of your text. Basically, this is almost a review lesson of stuff we've already done. The only difference is now you can have stuff besides x to the first power. So if we have an example 3.4a, it'd be really helpful is to actually share my screen. There we go. All right, example 3.4a, we have 3x plus 2 is greater than 5, okay? And just kind of reviewing how we would normally solve these before we deal with the higher exponents and things like that. So first thing we're going to do is we're going to subtract 2 from both sides and get 3x is greater than 3, divide both sides by 3, and we get x is greater than 1. Now, we could very easily graph this. We know what we're doing there, and we would know that then at point 1, we would leave a hole and shade everything to the right, okay, because it's not equal to, and we know that for sure it would point to the right because it's a linear inequality. And so we know we could write the interval 1 comma infinity, and we have those 3 ways of answering this question. And all that is well and good. The problem is that only works if you don't have x to a higher power. If you have x to a higher power, that means we're going to need to go through and examine each scenario to figure out which part of the graph should be shaded. We call this x is greater than 1. This number 1 here is what we call a critical number. In other words, it is simply the boundary between ranges that may or may not be true for the equation. So x equals 1 is the only value where it could change from being true to not true or vice versa. So we can just test something on the other side. In the textbook on page 139, they've tested 0 and 2. If you test 0, you get 2 is greater than 5. Well, that's false. If you plug in 2, you get 8 is greater than 5, and that's true. So we shade the side with x equals 2 on it. And so that's kind of an unnecessary step for this problem, but it's going to become a necessary step in future problems as we have x squared, x cubed, and so on, because that may actually change some of the ranges. So we'll need to go through and do this step by step. So on the top of page 140, you have your list of steps if you're a step-by-step person. And let's go on to example B. We have example 3.4b, where we have x squared plus x is less than 12. So we have x squared plus x is less than 12. The first step is to get it to essentially equal 0. I know it's not equal, but you know what, one thing at a time. So we have x squared plus x minus 12 is less than 0. Now, what we're going to do for a brief moment is kind of forget that it's less than. We're just going to make it equal to so we can find our critical numbers. We'll reintroduce the correct symbols here in a little bit. Okay, so we're kind of just purposely making a mistake here and writing equals 0. Okay, and so by doing this, we can find where it equals 0, where the changes can be from truth to non-truth and vice versa. And from there, then we can test certain points. So here now, we know what to do with this. We know we can factor this. And I'm not going to show the factoring here, but we would get x plus 4 times x minus 3. And this would equal 0. So that means x plus 4 would equal 0, or x minus 3 would equal 0. And so x would equal negative 4, or x equals 3. And so that means our boundaries are negative 4 and 3. Those would be our critical points. So if this is 0, negative 1, negative 2, negative 3, negative 4, negative 5. So this is going to be a critical point. Notice that equals is not a part of my original equation. I cannot just fill in the dot. So I know that that's going to be my boundary, and I know it's going to be not included in whatever my answer range or ranges may be. Okay? So that's one critical point, and then we're going to go 1, 2, 3, 4, and 5, and 3 is our other range. And again, notice I've left the circle open. Now the question is it the range over on this side of the line where it's from negative infinity to negative 4? Is it between negative 4 and 3, or is it from 3 to infinity, or some combination of 2 or more of those ranges? Okay, and so what we need to do is we need to find test points, and we want to find points that are going to make the math very easy for us. And then we're going to plug it in directdirectly to the original. So on this first range, I'm going to choose -5 as my check here. So we're going to have -5 squared plus -5, and we're going to see if that's less than 12, okay? And we're just going to plug in back to the original equation. So -5 squared is 20, minus 5 is going to be 15. Well, 15 is not less than 12, so that's wrong. So it's definitely not in the first segment. All right, then in the middle segment, let's go ahead and use 0, because that'll make things real easy. We have 0 squared plus 0 is less than 12. Well, is 0 less than 12? Of course. So we can go ahead and shade. Oops. Oh, I grabbed the wrong thing. We can go through and shade this middle region around those circles. Okay? So we have here our circles, and now the only question is the last region also a possibility? And so we're going to go ahead and just use 5. The book used 4, that's preference. I don't know, I'm just picking 5 because I can do the math real easy in my head. So we have 5 squared plus 5 is less than 12. So we have 25 plus 5, which is 30. 30 is not less than 12, so that range can't work either. We only have the range in the middle as part of our solution. Okay? So we have open dots, the middle portion, and if we were to write this in interval notation, this is from -4 to 3 with the endpoints not included, so we use parentheses. Okay? And that would be how we write this. If we're writing this in inequality notation, this would be -4 is less than x is less than 3. Okay? And those would be our solutions. All the blue there is the solution, essentially. All right, hopefully that's making sense. If you guys have questions anywhere along the way, please go ahead and just put it in chat, and I'll do my best to answer them. But in the meantime, we're going to go on to example C. If you need to come back and look at this, remember this is a video. You can always scrub back and look at it a little longer if you need to. But let's go ahead and continue on to example 3.4C. We have x cubed plus 4x squared plus x minus 6 is greater than or equal to 0. Again, one of the first things I'm going to do is kind of ignore the greater than portion. I'm just going to assume it's equal to 0 for right now so I can find my critical numbers. Now, because this is x to the third, we're going to need to go through and find all the possible zeros, because at this point we don't have a strict factoring method. So we have to find all the possible zeros, use synthetic division, get it down to something else we can factor. Okay? So just kind of as a review here, here's what we're going to do here. We have the factors of 1 in the front being our denominators, the factors of -6 at the end being our numerators. And if we divide by 1, we're just going to get the original factors. So if we take 6 and factor it, we're going to get plus or minus 1 as a possibility, plus minus 2 is a possibility, plus minus 3 is a possibility, and plus or minus 6. And then at that point, what we do is we can use synthetic division to find a 0. Now, they just plug in and test. We can also use synthetic division. It's entirely your call, whichever way you prefer to test. I personally, you know what, for the sake of time, I'm just going to plug it in. If we plug in positive 1, I get 1 cubed plus 4 times 1 squared plus 1 minus 6. Does this equal 0? We get, or equal or greater than. So we get 1 plus 4 plus 1 minus 6. We end up with 6 minus 6. That does, in fact, equal 0. So that is actually a solution. So I can factor out a 1 here. So we can do x minus 1. Keep in mind that if positive 1 works, it's x minus 1, because x minus 1 equals 0 then. And then we can factor that out from there. Oh, right, this is why I end up using synthetic division all the time, because either way we have to do it to find the next piece. All right, so just using the synthetic division, we're going to plug in 1. We have 1, 4, 1, negative 6. Bring down the 1. 1 times 1 is 1. 4 plus 1 is 5. 5 times 1 is 5. 5 plus 1 is 6. 6 times 1 is 6. Negative 6 times 6 is, negative 6 plus 6 is 0. So that's going to tell me, first of all, both I have x minus 1 as one factor, and then x squared plus 5x plus 6 as my second factor. And I can continue to use equals 0 for now to find the other two boundary points. And so if we factor this normally, we can go ahead and get x plus 2 times x plus 3. We just use the table method here. And now I know that x must equal 1, negative 2, or negative 3, because that's where all three of those parentheses would equal 0. So let's go ahead and draw ourselves a number line. All right, and let's mark our boundary points. Notice that, real quick, notice that equals is part of our solution, so we're going to fill in these dots as we mark them, because we know that the endpoints are going to be part of a solution. So I have negative 3, negative 2, and 1 as my 3 points, and so now I have 4 ranges to test, okay? So we're going to go through and make ourselves little lines for testing, okay? And the equation is going to be in the thing here. So let's go ahead and do the first range, which we're just going to use negative 5 for the sake of ease here. Whoops, I need to put it back on pen. So we have negative 5 cubed plus 4 times negative 5 squared plus negative 5, and I'm running out of room. I'm going to run into a problem here with that. So, all right, at this point, you just use your calculator. I can show it here. Well, I can't actually, because I needed to have Windows for that. If we put in a calculator that negative 5, or that negative 4, if we use that one, because it's the one the book uses, and then I don't have to refigure it out. If we use negative 4 as our test point, we find that this doesn't work because we end up with a value of negative 10 is greater than or equal to 0. That clearly doesn't work, so we don't include that range. If we plug in negative 2.5, or shown there as negative 5 halves, we get 7/8, which is greater than or equal to 0, and yes, it is. So we do go ahead and shade this region in between the two. If we use 0, we end up with negative 6 is greater than or equal to 0. Well, that doesn't work. So that's out. And then finally, if we use, they use 2 in this case. If we do that, we get 20 is greater than or equal to 0. So this range does in fact work. And so we'll go ahead and, go ahead and shade that portion as well. Okay, so that's, that would be our solution. And so then what we do is either in interval notation or in inequality notation, we write our answer. They're asking for interval notation, so we have from negative 3 to negative 2 inclusive, where we include the endpoints, so we use brackets, or from positive 1 to infinity. Remember, you have to always use a parenthesis with infinity. All right, and so these are our intervals. If I were to show this in inequality notation, we'd have negative 3 is less than or equal to x is less than or equal to negative 2, or negative 1 is less than or equal to x. Okay, these are all the solutions for this problem. Now, as we go on to example D, again, if there's a question, please put it in chat. As we go on to example D, one thing is that one or more factors can be repeated. Also, in addition to that, you might have sections next to each other that both work. So don't assume it's always going to alternate. Once you know one isn't, you can't just mark every other one after that. You have to go through and test every time. And let's show that through example D. All right, so we have x to the fourth plus x cubed minus 6x squared is less than 0. So again, for the first bit, we're just going to kind of assume that this thing is actually equal to 0. And I will be right back. All right, so what we're going to do for the beginning here is we're going to assume that it's actually equal to 0. So first thing I can do is I can factor out that common x squared at the beginning. So we have x squared goes into this, and we can take out, and we have x squared left plus x minus 6, and we're going to say this equals to 0. Then we can go through and factor this x squared plus x minus 6 normally using the table method. I'm not going to show that here. And we're going to have x squared times x minus 2 times x plus 3, and this is going to equal 0. Again, if you just use the table method, you'll get that same factorization there. All right, so then what we're going to do is we're going to go through and find where the boundaries are. Okay, so we have x equals 0 would work, x equals 2, or x equals negative 3 as our critical numbers. And so again, let's go ahead and get out our number line. We have 0, 1, 2, 3, negative 1, negative 2, negative 3. And let's go through and mark our points. So we're going to have, notice that, again, we do not have equals here. So we're going to use open holes instead of filled points. And so we're going to put a hole at 0, a hole at 2, and a hole at negative 3. And then what that's going to do is then we're going to test each of those ranges and see what works. We might have a couple in between that actually both work. So let's go through here and get this thing ready. Just trying to leave myself enough room to do the math. All right, so as we do this, if I test, say, negative 5 or negative 4, as the book does, you can see the work there, and we get 96 is less than 0, which is just obviously beyond false. Okay, and that's just at negative 4. All right, so if we test it at negative 4, that's not going to work. So this first range is out. Okay. If I test negative 1, okay, again, the math is shown there on page 143, we get negative 6 is less than 0, which is in fact true. So that means that this range is part of my solution. Then if we test 1, I'm going to get negative 4 is less than 0, which is also true. And so we're going to get this range as also part of our solution. Now we can't just fill in a solid line though, because there's still a hole in the graph at 0. So just mentioning that there. And then if we go ahead and test 3, we get 54 is less than 0, which is just obviously false. Okay, so it can't be that situation there. So we have these two ranges, yes, they're right next to each other, but we can't combine them into one because there's a hole in the middle. And so in interval notation, we represent this as negative 3, comma 0 with parentheses and 0, 2 with parentheses. Or if I wanted to use inequality notation, I would say that negative 3 is less than x is less than 0, or 0 is less than x is less than 2. Okay? Because if nothing else, by solving for that 0, we said where it can't be. Okay? So keep in mind that you have to check each thing by itself. If you ever, they don't have an example of it, but if you ever run into a point where only a single number is going to be included, for example, if we had equal to up here, and we're going to be included and they weren't right next to each other, if you have a number by itself, you just represent that number by itself in brackets if it's the only part of the interval, if that does come up. Okay, it didn't here, but if it does, that's how you would handle that. All right, homework tonight. If this will work. There we go. That'll do it. I'm just double checking the assignment so I make sure that I say it right. The numbers on the bottom were simplifications of the math shown on page 143 there. They went through and plugged in -4, solved the equation all the way down on the one side, and saw if it worked. That's where the number's coming from. I just wasn't showing it. I showed it in earlier pages. It's just a matter of okay, I will go back through that in just a moment. All right, you're doing practice 3.4 green problems as homework. Let me just explain a little bit better where I got those numbers from. Okay, I'm assuming in chat you guys are talking about these numbers down here. Okay, these are just you plugging in the numbers. So for example, on a previous thing here, when I went ahead and plugged in, okay, so I plugged in -5, I chose a point somewhere in my interval and plugged in and see if it works. If it works, it's part of the solution. If it doesn't work, it's not part of the solution. Here I plugged in the test point 0. Here I plugged in the test point 5. Okay, I just ran out of room to where I couldn't actually show all that math right here. So the math is shown in the example in your textbook. All right, did that clear things up for you guys? And then again, your homework tonight is practice 3.4 green on pages 143 and 144. That assignment is already on Google Classroom. It's just under the assignment that was due today because, yeah, I've rewritten assignments so many times I don't even know. So, yep, okay, good. Looks like that's clearing things up. Awesome. All right, if you guys have more questions in the next 10 minutes or so, feel free to just put them in chat and I'll either come back on or answer them in the chat. Past that, I will see you guys Monday. Again, this would only apply to one of you. If you're not going to be returning in person, excuse me, please let me know so I can be prepared for that. If you already are a distance learner, I already know. With that, and then let's see here. Yeah, that's it. So if you guys have questions, feel free to ask. I'll still be hanging around watching chat, and then I'll be starting pre-calculus here in a little bit. So I'll see you guys later. All right, welcome to Pre-Cal. Let's go ahead and get started. We're on 6.2, verifying trigonometric identities. We are on page 108. Page 108. Verifying trigonometric identities involves showing that one side of the identity is equal to the other side through the use of the fundamental identities. Real quick, this thing here, there is no standard process that will work for all trig problems. It takes practice and recall of the fundamental identities to become efficient. Often an identity can be verified in more than one way. When stuck, perhaps try working with the other side of the identity, and we have the guidelines listed here in blue on page 108. Rule number 1, work with only one side of an identity. You are not allowed to transfer items to the other side. That may sound weird given the rest of our problem-solving strategies. However, here's the issue with that. If you start trying to move stuff from one side, I'm not using the screen yet. If you start trying to put stuff from one side to the other, you're actually assuming that identity is true. And you can't assume it's true in order to prove it. Okay? So you have to work with only one side of the identity. It's very important. You typically start with whatever side is more complex because it's usually easier to simplify than it is to make more complex. So we start with whatever side looks worse. You want to substitute from the fundamental identities or forms derived from them. We're going to perform any algebraic operations such as factoring, removing parentheses, and simplifying expressions as much as possible. You want to just basically throw math at it and see what works. You want to get a common denominator or multiply by special forms of 1. You want to first convert one side of an identity completely to sine and cosine. When in doubt, get rid of anything that's not sine and cosine. That'll actually clear up a lot of problems. And then keep in mind the goal. The expression on the other side of the equal sign, whichever side you're not working on, is the goal. You want to take steps that will lead to that goal. It doesn't mean you'll learn how to make beelines straight. Boom, there's the goal. It means over time you'll get better at picking up what you need to do. This is a practice makes perfect thing. Okay? This isn't a thing where you do it once and you know how to verify trig identities. You need to go through and you need to verify trig identity, and trig identity. So that way you go through. It's kind of like proofs, except we're not writing statement reason columns. Okay? That's basically what we're doing. So here's what we're going to do. Let's go through a few examples. I'm going to go through them. You can always start with whichever side of the equation you want. However, when you have one that's clearly more complex than the other, that's where you want to start. So there we go. There's our basics. Let's look at example 1. We're going to verify 1 plus the tangent of theta is equal to the secant of theta times the cosine of theta plus the sine of theta. Okay. So as I verify this identity, I'm not going to touch the left side of this equation at all because the right side is clearly more complex than this equation. So because of that, and whoops, I don't want to do that. Here we go. So because of that, okay, I'm going to start working with the right side. So the first thing I'm going to do is I'm going to get rid of anything that's not cosine or sine. So secant is 1 over cosine, so I'm going to plug that in right off the bat. Okay, that's the first goal because a lot of things can simplify if you just have them in the same form, and it's really easy to get stuff to sine and cosine. Tangent is sine over cosine, and then everything else can be based on that. You have cotangent, which would just be cosine over sine. You have secant, which is 1 over cosine like here, and then you have cosecant, which is 1 over sine. You can easily get everything down to cosine and sine as your first step. Then as I look at this, I can do algebra here. I can distribute that 1 over cosine of theta. So I'm going to go ahead and do that. And so I'm going to have cosine of theta over theta, over cosine of theta. I'm distributing this fraction plus the sine of theta over the cosine of theta. Again, I'm not allowed to touch the left side. Okay, so then cosine over cosine, well, that's 1. Sine over cosine, hey, that's tangent. Okay, it does in fact work, and I proved it without transferring anything. You have to be careful. You cannot transfer anything. That's going to be your biggest temptation. All we do is we bring this down to say 1 plus the tangent of theta is equal to 1 plus the tangent of theta. That's all we do to the other side of our identity. Okay, so that's example 1. I'll give you guys just a minute while I go turn up the AC because it's a little chilly now. All right, let's go on to example 2. We are told to verify the cotangent squared of beta times 1 plus the tangent. Wow, that was bad even for me. 1 plus the tangent, is it just tangent or is it tangent squared? Tangent squared of beta is equal to 1 over 1 minus the cosine squared of beta. Okay, so clearly of the two, it depends on which you consider to be more complex, whether you consider the fraction to be more complex or the left side. We're going to start with the left side because it appears more complex to me, but that's again a preference thing. So cotangent, we can simplify that down to cosine squared of beta over the sine of squared of beta. Okay, just simplifying that, times 1 plus the sine squared of beta over the cosine squared of beta. And again, I'm not touching the other side, so I don't even write anything over there, so I'm not tempted to try to move stuff. Okay, I'm only focusing on the left side. And I keep coming down in a column so that it's very clear what I'm doing. I'm only manipulating one side of this thing to verify it. All right. Let's see here. Well, I can distribute, so let's go and do that. So I'm going to end up with cosine squared of beta over the sine squared of beta. Oops. Plus, and notice the cosine squared and sine squared are going to cancel in the second term, so plus 1 will be basically our operation there because everything just cancels. Your book shows that as 2 different steps. I just did it in 1. That's fine. You can very clearly see the mathematical significance there, so we're going to move on. However, on the right-hand side, notice that we have only one fraction, so let's go ahead and get a common denominator. That's what we're going to do. So we're going to have cosine squared of beta over the sine squared of beta, and I can represent that 1 as sine squared of beta over the sine squared of beta. Had you seen that earlier, you could have just canceled just cosine and left it as sine squared over sine squared. That would have been fine. It's a matter of what you see when you see it. So then we have cosine squared plus sine squared all over sine squared. Well, cosine squared plus sine squared is 1. So we're going to have 1 over the sine squared of beta. Okay? Which then, if we were to do this, we would get 1 over, and I have run out of room. Okay, which then, if we go through and look at sine squared of beta, I can rewrite that as 1 over 1 minus cosine squared of beta. Based on our sine squared beta plus cosine squared beta equals 1, we can just solve that for sine squared of beta. Okay, so just subtract cosine squared beta from both sides, and sure enough, that gives us the original thing we were trying to get to. Okay. The main one you need to make sure you remember and make sure you apply as needed is that sine squared of theta plus cosine squared theta equals 1. This in all its forms are really useful in this scenario. That's what I did to get from this step down to this step. Okay, that's what I applied. So that's really what's happening there. So make sure you guys are paying attention. This will take trial and error. Your answers may look slightly different from what's in the book. Expect that. My answers might be different from your answers. As long as you don't violate any of the rules and you get from point A to point B, again, it's mathematics. So either you do it right or you don't. It's not you're going to follow the exact same process. It's you're going to end up with the same result because as long as you follow the rules of math. Let me explain it that way. Now, example 3, we're going to actually do 3 times. Okay, and that's not just because 3 3s is fun. It's entirely because we're going to show how there's multiple different methods of attack. And so we're told to verify 1 over the cotangent of theta minus the tangent of theta, I did not make that fraction bar anywhere near long enough, is equal to the cotangent of, this isn't theta, this is phi. Why phi? Okay. Phi, and this is the cotangent of phi all over the cotangent squared of phi minus 1. Okay? So that's the idea. That's the thing we're going to do. So before I get too far into this, duplicate, duplicate, and back on the first one. That way I don't have to rewrite it 3 times. All right, so. All right, it doesn't matter. They're both basically the same amount of complexity. So we're just going to start working with the left side because why not? So first things first, let's get this thing all over to, well, we only have cotangent in the answer, okay? So I know we just said get everything in terms of sine and cosine, but if everything is in cotangent on the other side and I can easily get tangent to cotangent, let's do it. So I'm going to put 1 over there. 1 over the cotangent of theta, or no, of phi, goodness, minus 1 over the cotangent of phi. You're like, you put a fraction in a fraction. Yep, you can do that. Not a problem. Okay? Because that's the definition of cotangent and tangent. They're inverses of each other. So I can just take the inverse cotangent there and put it in. Okay, well, obviously I don't have a fraction and a fraction on the right side, so let's try to get this thing down to a single fraction. So let's do a common denominator. So if I take the left piece, if I take this piece here and multiply it by cotangent over cotangent, I'm going to get cotangent squared in the numerator and have cotangent in the denominator. So I'm going to go ahead and combine like terms, or combine things here. So I'm going to have cotangent of phi minus 1 all over the cotangent of phi, and I forgot that squared, so there you go. Okay, so that's squared. Well, here's the thing. What's the denominator of a denominator? Well, it's a numerator. So this cotangent of phi here on the bottom can just be moved up in place of that 1. So we end up with cotangent of phi all over cotangent squared of phi minus 1. And that equals exactly what we were doing. Okay? That check mark on the end is us saying, hey, yeah, this works. Okay, so that is important. I do tend to combine some stuff so that the book will list separately. As long as you're only doing that with simple math, it's fine. Okay, as long as you're only doing that with simple math, don't just skip the entire thing and say, yeah, it works. Okay. Now, this was solution A. Okay, in your book. Let's look at the next one, solution B. Same problem, different approach. If we look at the left side, notice that I know I'm going to have cotangent on the top. I'm going to have cotangent in the numerator of my equation, of my fraction. So what if I just start out by multiplying both the top and the bottom by the cotangent of phi? Okay, well then what's going to happen is on top I'm going to end up with the cotangent of phi all over cotangent squared of phi minus cotangent of phi tangent of phi when we go through and distribute. Okay, cotangent and tangent are inverses, so when we multiply them, we get 1. And sure enough, there we go. Okay, so that does in fact work, and so that's a very useful way of looking at it. That actually took very little manipulation at all. Notice it's really fast if you happen to see it. Okay, here's the secret with verifying stuff. The fastest method is the method you immediately see. It's not, you know, oh, the book only did it in 4 steps and I did it in 8. Yes, but how much longer would you have spent stuck staring at the problem trying to figure out how to do it in 4? The fastest method is the method that allows you to keep moving. Okay? That's how this works. So the reason why I'm showing 3 solutions here is not showing, hey, B is obviously better than A because it's shorter. I'm saying, hey, here's 3 ways that you could have attacked the problem depending on how you think. Okay? And that's very important. Don't underestimate that need to evaluate how do you think. Okay? If you think better by writing out stuff longer, if you saw a different approach than what I did, as long as you get there, it's fine. All right? Same as proofs. Okay? The method that is the best is the one that allows you to keep working. All right. Solution C. Not sure what just happened there, but okay. Solution C. We have, what if we said, okay, they're both equally complex, so let's start with the right side. What if we did that instead? Okay, because I showed 2 with the left. Let's look at the right side. Okay, let's see what we can do. Why did I copy this? Okay. We're going to just work with the right side here. We're going to keep the left side left alone. Okay? So real quick, first thing I can do is I can separate this out. And I can say this is 1 over the tangent of phi because I'm going to try to get rid of the numerator. Okay? So I'm going to do that first. And then, so that's one thing I can do. And then I can immediately go to cotangent is really cotangent times cotangent. So I can write cotangent of phi times 1 over the tangent of phi. And you might look at this and wonder, why would I only pull 1 out? Well, I know I'm going to still end up with a cotangent. So I'm going to leave 1 there and try to get rid of this tangent. Minus 1. All right, really not a whole lot I can do with that 1, but I could make a common denominator. Okay, this can be written as cotangent over tangent. So let's go ahead and rewrite that. So we have 1 over the tangent of phi. We have cotangent over tangent minus tangent over tangent. And what that's going to let me do is I can actually just combine this fraction, put a minus sign here, and only write, and I'm only doing this for the sake of space, and only write tangent of theta once, okay? Because we have common denominator now. Well, now we have 2 denominators inside a complex fraction that match, so they can cancel. And I get 1 over cotangent of phi minus the tangent of phi. So whichever one of those methods would have made the most sense to you is probably how you'll approach the problem. Okay? The trick to approaching this is to approach it yourself. It's not to look at what is the ultimate way of solving this. It's to go through and look at what do I see that I can do. All right, let me try that and see where it moves me. Okay, it didn't get me as far as I want, but I'm moving. What's the next thing I could possibly do? You just want to keep yourself moving. You're not trying to get from point A to point B. You're trying to get from point A to 1 step past point A, to 1 step past that, to 1 step past that. You will get to point B eventually as long as you keep that in mind that that's where you're aiming. Okay? That's the idea here. All right. Real quick before I let you guys loose, just want to go ahead and discuss your homework. Pre-cal, classwork. All right, you guys are doing 6.2 verifying trigonometric identities. That will be due on Tuesday, and you're only doing evens. Okay, so you're doing page 111 evens only. That's not due until Tuesday, so that way you guys have 2 days to work on it. There's quite a bit here. I know you two like to procrastinate because, I mean, so do I. So I can't really judge. Why is it fuzzy all of a sudden? My goodness. Hello. There we go. Autofocus just needs a hand sometimes. All right, so not sure how long that's been like that. Anyway, what I highly recommend doing is getting through like number 20 tonight and then doing through like number 40 on Monday. You're going to want to split this up over 2 days. Otherwise, you're going to burn out your brains, okay? Doing 20 of these verifications in 1 day is not something you should do, all right? I know you guys like to procrastinate. Honestly, again, I do too. Please split this one up. Trust me, okay? Past that, I will see you guys later. I will stay on for about the next 10 minutes watching chat or so. If you have a question, put it in chat. If I need to, I'll come back on to answer, or I'll try to answer your question in chat. But again, the key thing here is just do what lets you keep moving, okay? Even if you don't necessarily immediately see how it'll get you to your goal, if you see something, try it. Worst thing that happens, you have to break out the eraser, okay? This is why we do math and pencil, all right? I look forward to seeing you guys on Monday. If either of you are not going to be back on Monday, if you're going to go to distance learning, or you're just not going to be back right away, please let me know by a message, whether it be My School Works, text, or email, just so that way I can be more prepared to help you come next week. All right? Look forward to seeing you guys again. Have a good day.